Hello everyone, this is Sahil Sheikh and I welcome you to Effortless Learning. So today we are going to see some questions of time, speed and distance, and those questions are based on trains. Okay, so in this type of question you are going to see that uh, the train is crossing some object, okay, and there are two types of object, the object having length and the object does not have length. Okay, so let's see. So first, before going to the questions, we will be seeing the concept. Okay. So here, I have taken two types of object. One is point and one is having length. Okay. So points object means the object that has negligible length. So here, I have taken a point object. Okay. So the point object can be a pole, right? Signal pole or man or stone, milestone, you can say. Okay, so the train is crossing this pole, main, or milestone. Okay, so in those cases, we are going to take okay the object as point. That means the object without length. All right. Now in the second case, we have an object with length. Okay, so the object with length, it can be a platform, okay, or a bridge, or a tunnel, or it can be another train also, right? So the train will be crossing this kind of object. So how to solve the questions? Okay, let's see one by one. Okay, so here I have a train and having the length 200 meter, and let's say it takes 10 second to cross. Okay, let me write here. Okay, it takes 10 seconds to cross this object, okay, and I need the speed. So I have a train, okay, this train having length 200 meter and it takes 10 seconds to cross this object. So what is the speed of the train? How to find it? All right, so we okay, just apply the basic formula. We know that speed is equal to distance upon time. We have time, that is 10 seconds. uh, Let me write it here so that I can use that space. Speed is equal to distance upon time. I have time, that is equal to 10 seconds. But for finding the speed, I need the distance. Okay. So how to find the distance here? Okay. Here, when can I say that this train has crossed this object? When can I say that this train has crossed this object? When this point, right, the trail part of the train, okay, the end part of the train will reach here, right? Okay, that means this train is here now. All right, when the end part will be here, I can say that yes, this train has crossed this object. So if I take this point as a reference, okay, and this point has traveled from here to here. So how much distance this point has traveled? It has traveled, okay, this length, and this length is equal to the length of the train, that is 200 meter, right? So whenever a train crosses a object, an object having no length, okay, the distance traveled is equal to the length of the train. All right, so the distance is equal to the length of the train, and that is equal to 200 meter. Now it's simple. AC is equal to 200 divided by 10, and it is equal to 20 meter per second. All right, I hope it is clear. Now let's see with the object having length. Now the same train, now it is crossing a platform. Okay, the length of the platform is 300 meter, and now I am saying that it takes 50 seconds 50 seconds to cross this platform. So what is the speed of this train? Okay, again the same formula I'm going to apply, that is speed is equal to distance upon time. I have time, that is 50, but I need this distance. So how to find this distance? Now again the same thing, when can I say that this train has crossed this platform? When the end point, right, when the end point will reach here, right? That means this end point has traveled from, okay, this point to this point. So what is the length or what is the distance this point has traveled? It is this distance, that is 200 meter, and this distance 300 meter, right? 200 meter plus 300 meter. This 200 meter is the length of the train, and this is the length of the platform. Okay, so distance here, when the train crosses any object having length, we take the length of the train plus the length of that object. Okay, so here distance will be 200 plus 300, right? The distance traveled is equal to 200 plus 300, and it is equal to 500. So speed is equal to 500 divided by 50, and I have 10 meter per second. I hope you got it how to find the distance traveled. Okay, so let's go to the conclusion now. Okay, so I have written two conclusion here, that the train crossing an object without length, distance traveled is equal to length of the train, and when the train crossing an object with length, the distance traveled is equal to length of the train plus the length of the object. Okay, all right. Now we are going to see, okay, the object. Okay, we have objects. The objects can move also, right? So now we are going to see that when the object will be moving, what will be the effective speed? Okay, the distance is clear, right? The distance traveled is clear. Now we are going to see with the speed. Okay, now I have taken moving object. So this train is moving this direction, and this the object, obviously it cannot be a pole or stone, this can be a man, right? So the man is running or walking, it okay, either this side or this side. When the man will move to this side, it is moving in the same direction with the train. Okay, and when the object is or the man is moving to this side, okay, it is opposite to the train. All right, so let's say that the speed of the train is 220 meter per second. Okay, and a man, okay, I am saying that okay, this train is crossing a man, this train is crossing a man, okay, who is moving or walking 2 meter per second in the same direction with the train. So here we have to apply the relative speed. Here the effective speed will be changed, right? In the case of steady, when it will be steady, okay, stationary object, the speed will be same. There is not any effect on the speed. But when the object is moving, okay, there will be an effective speed which is not 20 meter per second. All right. So I am taking both the case. So when the man is moving in same direction with the train, same direction of the train. Okay, here the relative speed, okay, when the direction is same, what we do, we subtract the speed. That means effective speed will be, okay, 20 minus 2. And when it will move, when the man is moving in opposite direction, right? So the effective speed will be, okay, here we have to add the speed. Okay, all right. Now here I have taken two trains, right? A train, one train is crossing another train. So here, if I'm taking this train as a reference and this train is moving to this side, so if this train is moving to this side, that means opposite to this train, so effective speed will be, right? Effective speed will be, I'm taking, okay, S1 and S2, then it will be S1 plus S2 because they are moving in opposite direction. And if this train is moving to this direction and this train has higher speed, right? I am taking here condition S1 greater than S2. So effective speed will be S1 minus S2. Okay, all right. So here, uh, object moving in opposite direction. So the relative speed or the effective speed will be speed of the train plus speed of the object. And when object moving in same direction, the relative speed or the effective speed will be speed of train minus speed of object. Okay, all right. I hope the concept is all clear. Now let's jump to the questions. So the first question is, a train 400-meter long is running at a speed of 72 km per hour. Okay, in what time will it pass a pole? So we have the formula, speed is equal to distance upon time. And I need time, so it will be equal to t is equal to distance upon speed. I have the distance. Okay, the distance is equal to the length of the train and this is equal to 400 meter. And speed is in kilometer per hour, right? And here we have meter and the options are also in seconds, so we are going to convert this kilometer per hour into meter per second. And what is the conversion? It is 72. Okay, we multiply by 5 upon 18, right? So it will be 4 times, so 20. So 400 divided by 20 and it will be 20 meter per second. So option fourth. Now the next question, here we have a train 300-meter long is running at a speed of 54 km per hour. In what time will it pass a bridge 150-meter long? So again we are going to apply the formula. We have speed is equal to distance upon time. So time is equal to distance upon speed. Okay, distance. Now the train is crossing an object having length. So the distance traveled will be equal to the length of the train plus the length of the bridge. So it will be 300 plus 150 and that is equal to 450. And speed is equal to, we have 54 but in kilometer per hour, so we have to multiply and divide it by okay 5 and 18, so 3 times, uh, 3 times. Okay, 5 multiplied by 3, it is 15. So time is equal to 450 divided by 15. How many times? 30 times. So time is equal to 30 seconds. Now the next question. A train 525-meter long is running at 72 kilometer per hour. Okay. When will it pass a man running at 9 kilometer per hour? Now the object is also moving, and it is moving in the same direction, and we need time. So we know the formula, that is time is equal to distance upon speed. Here the distance is equal to the length of the train, that is 525, and speed, here we are not going to take, okay, this speed only, because the object is also moving now. So this speed, we have to take the relative speed or effective speed. So it will be 72 minus 9. All right, and this is equal to 63. Okay, and now it, okay, this is in kilometer per hour, so we have to convert it into meter per second. 5 upon 18. So 9 twos are and 9 sevens are. Okay, so speed is equal to 30 by 35 upon 2. Okay, now don't make it 17.5. Okay, otherwise it will make the calculation difficult. So time is equal to 525 divided by 35 by 2. So it will be, okay, this 2 will come here. So 525 multiplied by 2 and 35. Okay, so if I take with 5 7 times, so 1 time and 0 5, right? So with 7 it will be 15. So time is equal to 15 multiplied by 2, it is 30. Okay, so option second, 30 seconds. Okay, now this question you can pause the video and try to solve. So we have the question, that is a train 450-meter long is running at 72 kilometer per hour, and again the time has been asked that when will it pass a man running 9 kilometer per hour in the opposite direction. All right, now it is moving in opposite direction, that means we have to add the speeds. So time is equal to distance upon speed. Distance we have 450, and speed we have to add it 72, okay, plus 9, that is equal to 81 kilometer per hour. So we have to convert it by 2 times, it is 9 times, so it is 45 divided by 2. So time is equal to 450 45. This 2 will come here, so multiply by 2, 10 times 20. Option 2. Well, let's move ahead. So here we have a question that a train 300-meter long is running at a speed of 54 kilometer per hour. At what time will it pass a train 250-meter long running? Okay, now this train is crossing another train. Okay, and we have given the speed of this train and the length of the train, and we need to find the time. Okay, so directly we can apply the formula, that is time is equal to distance upon speed. Here this train is crossing and another train, that means, okay, this train is crossing an object having length. So the distance traveled will be, okay, the length of this train plus the length of this train, that is 300 plus 250. The length of the train 1 plus the length of the train 2, and this is equal to 550. And speed, because both the objects are moving, so we have to take the relative speed. So here we have 54 and this one is 36, so 54 minus 36, 18 kilometer per hour, so we have to do 5 upon 18. So the effective speed or the relative speed is 5 meter per second. So time is equal to 550 divided by 5, and this is equal to 110. Well, we don't have any option 110 seconds. Okay, 110 second is the option. Okay, again we have a question that is, a train 100-meter long is running at a speed of 54 kilometer per hour. Okay, at what time will it pass a train 150-meter long running at 45 kilometer per, okay, in the same direction? I think here we made a mistake. Here it was moving in opposite direction. Okay, so here this was moving in opposite direction. Okay, so here the correction is here, that we have to take the effective speed is 54 plus 36, and this is equal to 90 kilometer per hour, so 5 upon 18, okay, 5, so it will be 25 meter per second. So the effective speed is 25 meter per second. All right, so time is equal to 550 divided by 25. So how many times? 25, okay, 2 times it will be 50, so 2 times, and again 50, so 2 times, 22 seconds. Okay, we don't have any option with 22 seconds. Okay, so 22 second is the right answer. Now here the trains are moving in the same direction and we need to find the time. So time is equal to distance upon speeds, and distance is equal to, okay, here you in each question I have, okay, calculated time only. Means here what I did, that I have taken each type of question. Okay, the train objects are moving in the same direction, in opposite direction, just for clearing the concepts. Okay, how to apply the concept. So distance is equal to the length of these two trains, so 100 plus 150, and speed is equal to 54 minus 45, because they are moving in the same direction. Okay, it is 9 kilometer per hour and 5 upon 18, so 5 upon 2, the effective speed. So it is 250 upon 5 upon 2, so 2 will come here, so 25, 5 multiple, so t is equal to 100 seconds. Okay, now let's see the next question. We have given that a train 150-meter long takes 30 seconds to cross a bridge, and the length of the bridge is given, that is 500 meter. and how much time does it take to cross a platform of 370 meter long. So here we have two scenarios. Okay, in first scenarios the train is crossing a bridge, and in the second scenario the train is passing a platform. Okay, all right. And here we have given the length of the train. Okay, in the both the cases the length of the train will be same. Okay, here we have given the time and the distances. All right, and here we have given the length of the platform, and we need to find the time taken. Here I have given the distance, that is equal to 150 plus 500, that is equal to 650, and the time taken is 30 seconds, and speed we need to find. And here I have given the distance is equal to, because the same train is crossing this platform, so we have to take this length only, 150 plus 370, that is equal to 520. And we have no speed, and we have, okay, we have no speed, and we have to find the time. So we know that time is equal to distance upon speed. Distance we have 520, but we need the speed. Okay, here there is no comment of the speed, so the same train is crossing the platform as well as the bridge, so we have to take the speed as constants. Okay, that means the speed of the train, okay, throughout is constant, that we are going to use this speed. Okay, the speed is same, so speed is equal to distance upon time. It is 650 divided by 30, so it is 65 upon 3. Now don't, okay, make it a number with point. So time is equal to 520 divided by 65, okay, by 3, so this 3 will come on the numerator, so 13 5 times, 4 times, so 40, and 8 times, so it will be 24 seconds. Option C. All right, you got it, how to solve it. But this is a quite lengthy solution. Okay, we need to solve it within a minute. So how to solve this question within a time limit? Okay, we have an alternate solution, but for this, okay, because we have speed constant, okay, whenever we have one component, okay, we have the formula, that is speed is equal to distance upon time. Whenever we have one component is constant, okay, uh, I'm repeating it again, that whenever we have two scenarios or two cases, okay, here we have two scenarios, and in these two scenarios we have one thing is constant or same, and that is the speed. Okay, in this scenario and in this scenario the speed is same, that means the speed is constant in both the cases, so we use a relation, okay, a ratio, whatever you want to say. So here let's see, if in this formula, okay, we have one component constant, then how to apply the formula. Here I have written already everything. When, okay, so we have the formula, speed is equal to distance upon time, or you can write it as speed speed multiplied by time is equal to distance. Okay, both are same. So we have three components, so I have taken three conditions. The first condition, when the distance is same or constants. I have two cases, right, 1 and 2, and in both cases the distance is constant, means if there is a train and the train is traveling a distance here and here, both are same. So in that case, we have a relation with speed and time. That is, we can say that the speed multiplied by time of this scenario is equal to the speed multiplied by time of this scenario. Okay, so we can write the relation as s1 t1 is equal to s2 t2, or I can write that s1 upon s2, that means the ratio of the speed of both these, okay, these cases is equal to t2 upon t1. Okay, here there is a high chance of making mistake, t1 upon t2, but we have to take t2 upon t1. Okay, the inverse. Okay, so s1 upon s2 is equal to t2 upon t1. Now when speed is same or constant, we have to take d1 upon d2 is equal to t1 upon t2. Simple. Here 1 1 1 2 1 2. And when the time is constant, we use s1 upon s2 is equal to d1 upon d2. Okay, all clear? So here in our case, in this question we have speed is same, so what we are going to use, d1 upon d2 is equal to t1 upon t2. Okay, so let me erase this. Okay, let it be. So here speed is same, in both cases speed is same, so we are going to use t1 upon t2 is equal to d1 upon d2. Now we have d1 given, that is 150 meter, plus 500 meter, that is 650 meter, and d2 is 150 plus 370, uh, that is 520 meter. All right, this one is given 30, and we need to find time 2. Okay, so by applying this formula you can find, okay, the solution within a second, not within a second, within a minute. So 30 upon t2 is equal to 650 upon 520, and 0, 5 times with 13, 4 times with 30, and here we have to take the cross multiplication, so t2 is equal to 30 multiplied by 4 by 5, so 6 times it is 4, so it is equal to 24 second. Okay, so whenever we okay, so keep in mind that whenever we have two cases, and in both the cases we have same, okay, one component is same. Okay, the condition is that there must be one condition, one component same. Okay, then only we can apply the relation. All right, so okay, so if you want, then I can bring a, what to say, that derivation, that how can we find these relations, that s1 t1 is equal to s2 t2. Okay, I will bring a video on this concept. Okay, now let's move to the next question. So here we have a train with a uniform speed crosses a platform, and the length of the platform is 160-meter long. And okay, here also we have given two scenarios. So a train with a uniform speed crosses a platform 162 meters long in 18 seconds, and another platform 120-meter long in 15 seconds. So the speed of the train we need to find. Here in this we don't have the length of the train. So how to find it? In first case, and again we have two scenarios, so we are going to take that we don't have the length of the train. So the length of the train I am taking as length of the train, I am taking as x meter. So here the distance will be x plus the length of the platform 162, and here we have the distance is equal to x plus 120 meter. So x plus 162 meter and x plus 120 meter, and here it takes 18 seconds and here it takes 120 seconds, and we need to find the speed of this train. So how to find? Okay, if I got this x, okay, then I can apply the formula speed is equal to distance upon time. So for that I need to find this x. So how to find it? Again, in both the scenarios, okay, in both these cases we have one component is same, one component is constant. What is that? That is speed, right? Speed is same in both these cases. So I can relate it, d1 upon d2 is equal to t1 upon t2. So here I can apply that x plus 162 upon x plus 120 is equal to t1 is, okay, here t1 d1 d2 t2. So t1 is 18 and t2 is 15, not 120. Okay, with 3 it is 6 times and 5 times. So we have to take the cross multiplication. So 5x plus uh how much? 5 twos are 10 and 5 6 are 30 and 1, so it is 810, and this equals to 6x plus 12 multiplied by 6, it is 720. So we have 6x minus 5x, it is equal to x. So x is equal to 810 minus 720. So here we have x is equal to 80 and plus 10, it is 90 meter. Okay, so x is equal to 90 meter. So the length of the train we got, that is equal to 90 meter. Now we need to find the speed. So I can use any of the cases. Okay, so here speed is equal to distance upon time, and distance is equal to x plus 162, that means 90 plus 162, so it will be equal to 252, and time is given, that is 18. So 252 divided by 18, so how many times? 1 times, we have 7 remaining, so 72, and it is 14. All right, so 14 kilometer per hour, and options are also in kilometer per hour, so option A. Okay, now let's move to the next question. A train 180-meter long moving at the speed of 20 meter per second overtakes a man moving at a speed of 10 meter per second at the same direction. The train, okay, this question is for you guys. All right, you need to uh, give the answer in the comment section. Okay, now this question. A passenger train 150-meter long is traveling with a speed of 36 km per hour. If a man is cycling in the direction of 9 km per hour, the time taken by the train to pass the man. Again, uh, an easy question. You need to write the answer. Okay, you need to solve it by yourself and write the answer in the comment section. Okay, okay, this is quite what to say that not difficult but tricky question, and I have taken this question, okay, so that the concept will be crystal clear. All right, because you will have to apply the knowledge here. The question is, two trains are running in opposite direction. They cross a man standing on a platform in 28 seconds and 10 seconds respectively, and further it is given that they cross each other in 24 seconds. So what is the ratio of the speeds? How to solve it? We have given two scenarios. First, okay, up to here we have given two scenarios. All right, two trains are given that, and they are moving in the opposite direction, and both the trains are crossing a man. Okay, and one is crossing in 28 seconds and another is crossing in 10 seconds only. All right, and we need to find, and they cross each other in 24 seconds, and we need to find the ratio of their speeds. So how to do it? Okay, all right, in the first, I'm writing here like this, two scenarios, one and two. So we don't have, so what to say, that the length of the train, so I'm taking as d1, and it is equal to nothing. Here it will be d2. We have speed, okay, we don't have speed also, so s1, s2 is also not given, but we have given the time. So t1 is equal to 28 seconds and t2 is equal to 10 seconds. Okay, here we have two scenarios. Okay, but nothing is common, nothing is constant, or nothing is same, whatever you want to say. So we cannot apply the relation here. Okay, here we cannot apply the relation because, okay, out of the three components we don't have anything same here. And third, we have asked that, we have third scenario, they cross each other in, okay, 24 seconds. So when they are crossing each other, the distance traveled will be d is equal to d1 plus d2, and we need to find the ratio of the speed, and the combined time we have given t3 is equal to 24, or d3 is equal to d1 plus d2. All right, now what I can do here is, simply I can apply the formula that s1 is equal to d1 upon t1, that means d1 upon 28. So I can write that s1 28, s1 is equal to d1, and in the same way s2 is equal to d2 upon 10. So 10 s2 is equal to d2. Now here the effective speed also, okay, or s3 is equal to s1 plus s2. All right, so if I apply the formula here, because I have given the time, so speed s3 is equal to d3 upon t3. So s3 is equal to, or the speed is equal to s1 plus s2, and d3 is equal to what, d1 plus d2 and upon 24. I hope you are getting it right. What we are doing here, that we have given three scenarios here. Okay, in first two scenarios there are two trains, they are crossing a man and the time is given. So here we can okay, we are trying to find the relation between the distance and speed in both the cases separately, and in the third cases they are crossing each other. Okay, so I have taken the distance traveled by them is the length of uh, those two trains, and time is given, and effective speed also will be, because they are moving in the opposite direction. So the speed will be not s1 or s2 because they are moving collectively, right, and in this opposite direction. So we have to take the effective speed, or the relative speed is s1 plus s2. All right, and now I applied the formula simply. Speed is equal to distance upon time, but here we have the speed is equal to s1 plus s2, and the distance traveled is d1 plus d2, and time we have given, that is 24. But here we have s1 and plus s2, and d1 is equal to what, it is 28 s1 plus 10 s2 upon 24. So take next page. If I, okay, let me write here, s1 plus s2 is equal to 28 s1 plus 10 s2, 28 s1 plus 10 s2 and 24. So if I take 24 here, it will be 24 s1 plus 24 s2 and 28 s1 plus 10 s2. So 24 s1 plus 24 s2. Now I have to take the s1 and s2, okay, the same term in the same side. So 28 uh, 24 s2, okay, take the s2 to this side. So 24 s2 minus 10 s2 is equal to 28 s1 minus 24 s1. So here we have 14 s2 is equal to 4 s1. With 2 it is 2 times 7 times, so 7 h2 is equal to 2 s1. Okay, so h2 or s1, I am taking s1 upon h2 is equal to 7 upon 2. So the ratio is 7h to 2. Okay, I hope everyone got it. Okay, so in the next video I will take lecture on same time, speed and distance, but on the concept of boards. Okay, boards and streams. So subscribe to the channel and like the video. Okay, bye bye, take care everyone.